All right, let's get started. As always, I'd love to see some questions in the chat if you guys have questions. So today's lesson and tomorrow's lesson are on more advanced material. I will acknowledge that. And there's a method behind our madness, trust me. But there's a few pieces of sort of somewhat more advanced Java syntax that I'd like you to see. And you can really think of these two lessons also as kind of working together. We start today talking about anonymous classes, and then tomorrow's lesson gets into kind of a continuation of this topic and into lambda expressions in Java. And to be honest, lambda expressions are a really nice feature of Java. And it's an advanced feature. It's understandable to us once we get there, and once we have all the pieces in place, which you almost do. But on the way there, we need to talk about this idea of an anonymous class. So and I'll just vamp here for a few minutes while we get started. Anonymous classes are a way to create an instance of actually what you create is an instance of a class that either descends from another class or implements an interface, and then can customize the implementation or that extension. And so let's look at this as an example. So I've created an interface called adder that has a single method. And so to implement this interface, I need to implement one method called add2 that takes a single int argument, returns an int. I can create a named class, right? So if I say add1, so here's a way to create a named class that implements adder. We've already seen this. This is a review. So to implement the adder interface, I have to have a method called add2 that takes a value, and then I could say return value plus 10 or whatever. And so I can create an add1 class that implements adder. This is a named class. It has a name. The name is add1. And let's say this adds 1, right? Because it is called add1. And now, if I wanted to, I could create I could do something like this: new add1 dot add1, and I could add it to 8 or whatever. Why is it add2? Sorry, I need to use the right method name. And that works. But there are times in which in Java we really want to, and we're going to see some examples of this coming up soon where this is really useful. We want to create an instance of a class, and we want to be able to override or implement some of the methods, but we don't want to go to all the trouble of creating this whole named class, right? You can always create named classes in Java. That's always a way to solve this problem. But there are certain times when you actually want to sort of say create like an implementation of a class just as a one-off, right? And Java anonymous classes allow us to do this. So what anonymous classes allow is they allow us to create an instance of something that implements, in this case, adder, but without naming it. So here's an example down here. So these two are essentially the same. I'll sort of bracket them off a little bit here. Add1, my capital add1 is a class, a named class, and when I create instances of it, I get a method called add1. Add2 that adds 1 to its argument. This, on the other hand, is known as an anonymous class. So this reference variable holds a reference to a class that implements the adder interface, but this anonymous class has no name. And there's no way for me to call a constructor because it has no name. And there would be if I wanted to create another one of these, I would have to cut and paste the code. So normally, like if I wanted to create two add1 instances, I could say adder first add1 is equal to new add1. This is the name class. And then adder second add1 is equal to new add1. And that's another name. This is for named classes. So I can create as many instances of this class as I want, or I could have the reference variables set to each other or whatever, right? But with a named class, I have something I can put after new. And I can create new instances of that, and it can have a constructor or whatever. With this anonymous class, I don't have that. Instead, what I do is I provide rather than having the class declaration that contains the class body, I provide the class body, including the methods that I'm overriding, when I create the instance of that anonymous class. So there are a couple of things that are new here for us. I mean, obviously just the syntax of being able to have a class body be part of the object creation, right? I'm both creating an object and defining how it works in a single statement. The other thing that's weird here that we haven't seen before is this. So new adder. We've seen new, but in the past, the thing that follows new has to be a class that I can create. I can't create instances of an interface. So down here, if I wanted to say adder not gonna work is equal to new adder, I can't do this because Java is going to say adder is abstract. And really, remember we talked about abstract classes. Interfaces in Java are almost just sort of a special case of that, right? So you can think of interfaces, for at least from the compiler error perspective, as being sort of like an abstract class. I can't create one. I can extend it, I can implement it, but I can't create it directly. But here I can, and the reason is that I'm providing this implementation right away, right? So if you think about it, if I try to create an interface, it's like, well, how are you going to implement the methods? When I create an anonymous class that implements an interface, I have to pass the methods, the implementations of the methods alongside this. So, for example, if I just tried to do this, I would have the same problem. And you'll see, look at the name of the class. Isn't that kind of cool? So even the compiler knows that this is an anonymous class, and it has this name. The name refers to, in this case, we wrap this code when we actually run it. We wrap it in a class called capital M main, and I think the $1 just indicates like that's the first anonymous class that we've created in this one. I think if let's try this, right? Let's try stripping out the implementation for this one. Yeah, and then you see two. So anyway, even the compiler is having a hard time naming these, and of course that's because they don't have a name, so it spits out this sort of constructed name, right? That's not like I can't use that as part of new, right? I didn't even know what it was until I saw the compiler error. So when and if I added another, let's say I add another method to this, this is just a silly one, right? And I'll get rid of this because this is definitely not going to work. Now I'm going to see the same problem. So when I use this pattern of creating an anonymous class that implements an interface, the body that I provide has to completely implement all methods required by the interface. If I miss one, Java's going to complain. So these are anonymous classes. So again, there's this question of sort of like what do I actually do with these, right? So we spend a fair amount of time sort of just in this lesson going through the syntax. The other thing about this that's kind of interesting, right? And this is something that requires a little bit of explanation, is this idea of variable capture. So let's look at how that works. So let's create an int first, and we'll set that to 10, or we'll set that to 1, and then we'll say variable plus first. And so this is going to work. And what's interesting about this, so here's, well, actually, so far you may think, so what? Like, first is, because when I actually call, I'm going to get rid of this. It's like the anonymous versions of this. So when I actually call add 1, now it's math. When I actually call add 2 down there on line 20, first is still in scope. But let's make this more interesting. So let's write a method here called, we'll have it be a void run adder, and have it take an adder as an argument, and then maybe a value to add to it, 2, and we'll say system.out.println adder.add2, add 2. Okay. So now let's call run adder, and we'll pass it add 1 and 1, and that seems to work. Gotta get rid of these guys. And so now what I want you to understand is that it's not actually accessing the variable of first down here when I call add 2. What's happening is when I create the instance of adder, any variables that are in scope that are used within the body of the class are captured, meaning their value is captured at that point. So it's almost as if you did this, right? Here's another way to think about it. So I can't write a constructor for an anonymous class, but I can do initialization. So I could say private static well, I'll just make it a private int value is equal to first, and then I can't use value because I'm already using that. I'll just use v is equal to first, and then first plus v. That also works. So I can use it here as well to kind of initialize this private variable. So the idea is when this gets created, Java uses the current value of first inside the class. One thing that it will then prevent me from doing, which we looked at a little bit later, is if I change the value at first, because this causes people conceptual difficulty, right? And this is the compiler trying to help you. So let's walk this through, right? And let me just actually put first back in here, okay? So it's kind of like, what should happen here, right? I created this add1 anonymous class, okay? The add2 method references a variable called first, okay? When I created the class, first was 1, but then on line 12, I changed first to 10. And so when I actually get around to running this method, which I don't do till down here on line 22 when I call runAdder, what should happen, right? Because at this point, when I created the class, first was 1, but before I actually ran the method, first was changed to 10. And so what the compiler does is it essentially copies the values of those variables into the class when it's created. And if now this compiler error is preventing us from seeing this, but what you would see here it would still be 1, right? But to prevent you from making mistakes in terms of how you think about this, the variable is the Java compiler will prevent you from updating that variable after the class is created. Okay, good. What else? So I should check and see if people have any questions. I mean, this is kind of it. I'll go through a little bit of this example, right? So, and this is today and tomorrow we're going to kind of go through this example in a couple ways. And this is a case where, so let's, we've looked at this pattern for counting an array. And we talked about this like a month ago as being one of these patterns that we use in imperative programming. Right, I have a count variable, I set it to 0, I go through the array, I test something about the value, and if it's true, I increment the count, and when I'm done, I return the count, right? That's how this works. So far, given the skills that we've acquired, if we wanted to count a bunch of different things about the values in this array, we would have to provide a bunch of different implementations of count, right? So here's an implementation that counts positive values, counts negative values, counts even values. We could create one that counts odd values. We could create one that counts values that are multiples of 6. We could create one that counts values that are within a particular range. We could create one that counts values, whatever, right? And you can imagine, like, there are lots of different uses for this type of function, right? So if I was, let's say I'm doing a histogram, for example, I may want to take like an array of student scores on an exam and bin them, right? So I want a count of the number that are between 90 and 100, a count of the number between 80 and 90, a count of the number between 7 and 80, 60 and 70, whatever, right? Or I could do it in smaller bins. And so, I don't want to have to write count between 60 and 70, count between 70 and 80, count between 80 and 90. I mean, these functions are getting really, really tedious, right? And they're also similar. That's the other thing I want you to notice about this, right? Count array positive and count array negative are literally identical except for one symbol. Now, if I look at count array even, it's a little bit more complicated and I have to swap this out, but it's really just you can think of it as just the conditional expression inside this if statement that's changing. Everything else is the same. And so it seems really tedious to have to rewrite this over and over and over again, right? And it seems like, is there a way that we could set this up so that the logic, so there's two parts of this problem. There's kind of like the structure that we use to go through an array and count values, and then there's the thing that we're counting, right? There's some logic that we apply to, so you can almost think of it as a method, right? And I actually think it's a good way to think about it. There's a method that we're applying to each value. That method should return true or false. And if it's true, we count it. If it's false, otherwise. So here the method is value is greater than or equal to 0. So I could write that method down. Here the value, the method is value is less than 0. I could write that method. Here the value is value mod 2. I could write that method. So all of these are like these little methods. So what we really want, we'll talk about this more tomorrow when we kind of at least do a little shout out to what's called functional programming, is what I would love to be able to do, and Java makes this tricky, is I would love to be able to pass a method to this function. And essentially the way this would look is I would say if method value is equal to true, or even if just method value, then I count. And then my method could be anything. It could be any method that takes an int and returns a Boolean. Now there are some languages, including Python and JavaScript and Haskell and a bunch of other things, in which this is very, very natural. But what I really need here is a way to pass a method to another method. This is sometimes referred to as this count function would then sometimes be referred to as what's called a higher order function. It's a function that takes a function as an argument, right? Now, how do we actually do this in Java? And so the problem in Java is not a language that allows us to do this directly. We cannot pass a method to another method in Java. In Java, every variable stores either a primitive type or an object reference. That's it. There is no way to store a reference to a method. Again, we'll come back and talk about this tomorrow when we talk a little bit more about defined functional programming, but one of the characteristics of a functional language is that you can do this, right? You can pass a method to another method. Methods, functions in functional programming are first-class citizens in the language. You can save them to variables, you can return them to functions, you can pass them to functions. They're just like every other piece of data. Java doesn't allow us to do that. So the question is, how can we work our way around this, right? Is there a way to get something similar with Java? And there is. And so let's kind of go through this because it's a fun example to walk through. The way is, so I need something that I can call to test whether or not I should include the value in the count or not. And so what I need something that tells that I can pass to this method that will ensure that it has to be an object, right? Ensure that the object has this method that I can call, and that the method has a certain signature. It can take a certain argument and return something. And what I'm really describing here is an interface. And so let's try to write that interface, right? So I'm going to call that interface should count. And it really just needs a single method. And you could name this whatever you want. The interface name and the name of the method are up to us, right? I'm going to call this method include. It needs to return a Boolean. That's what I need right here. I need something that evaluates to a Boolean. And it needs to accept an int, because that's what I'm testing. This particular counting method takes an array of integers. So what I have here is an integer. And I'll call this include, and it takes an integer value, okay? So this is the contract, right? The contract now, so what I'm actually writing now is a method that uses an interface, because what I'm going to take here as my second argument is an interface. Should include, I don't know, we'll call it includer or something like that. And then down here what I do, and it's not quite as nice as I would like, but I call includer dot include. I'm going to call this count array. Okay. So now I'm moving in the right direction, okay? In the sense that I've refactored my count array method so that now I can count based on any criteria. So what I really did to make this possible, again, is I established an interface. You saw it, I defined it, right? By defining an interface, I'm breaking the problem into two parts. There's this code that will always do the right thing in terms of counting an array. And all it needs, remember we talked about comparable? It was like, all I need to sort is you to tell me how to order two items. All I need to do a count is for you to tell me whether or not I should include an item or not. And I don't care how you do that. We were going to agree on the interface here, where there's a method called include that I can call and pass an int and return a Boolean. Other than that, the logic for implementing that is up to you. So let's look at, so now what let's do is let's create a named class that implements should count. And then we'll see how that works. So let's call that, I'll make a public class should count positive, and that implements should count. And now what I'll do is I'll say my implementation for this include method is return values greater than or equal to 0. Okay. And now what I'm going to do is I'm going to try to run this. I'm going to call count array. I need to pass it the array, and then I need to pass it something that implements should include. And for now I'm going to use this named class should count positive. And I need one more and should count. Oh, sorry, should count. And I'll call this like counter or something. Include. Cool. So this works. Okay. And so now if I wanted to, I could create a should count negative, should count even, should count odd. But still, I mean, on some level, that's still better than what I had before, because I'm separating out the two parts of the problem. I have this loop. So if you think about it, even if I just cut and paste this class and change it, I'm still cutting and pasting less code than I did in the past. But I still have this problem, which is that I don't know, what if I want to count something weird, right? What if I want to count values that are in a range, right? Like I said before, I want to run a histogram. I don't want to create a should count between 60 and 70 class and a should count between 70 and 80. And so what I would really like to be able to do is pass as an argument a custom piece of counting logic. So I can do this now. I can pass the counting logic to my count array function. I've set up this abstraction barrier between the two where the count array function just counts based on some criteria, and I provide the criteria separately. But what I'd like to be able to do is actually not have to create a named class for every criteria that I might want to count. Instead, what I'd like to do is be able to just create my own criteria on the fly. And that's where we see the use of anonymous objects. So instead of this, I would say should count. This is an interface, but I'm good as long as I provide an implementation here. The function that I need to implement is called include. It takes a value as an argument, and then I'll say return value is equal to 1 or value is equal to 5. I'm just doing some sort of random criteria here. And now you'll see it works. Counts 2. And so now let's blow away our name class. So now, and this for today, and I'm very tempted to take the next step, but I won't because I don't want to ruin tomorrow. But this is as good as we can get. But it's still pretty cool in the sense that, and as I point out in the walkthrough, I mean, count is not a particularly complicated function. But what we started off with is having to basically create a bunch of different cookie cutter implementations of the same function for different criteria. Despite the fact that every time we cut and paste one of those, it would, some angel lost their wings somewhere, right? Like this is just a sad thing to do in your program. Now we've set things up so we identified a pattern here, which is, hey, like every single count array function looks the same except for this one spot. And so is there a way to abstract away the decision making about whether or not something should be counted from the rest of the machinery that does the count, the for loop, blah, blah, blah. And so we did that. We added a new value to our count, a new argument to our count array. So now what you do to count an array is you tell me, here's the values, and then here's the logic that you use to decide whether or not a value should be counted. And the logic can be anything you want. It could be, now if you were going to count a lot of arrays in certain ways over and over again, you might create some named classes to handle those cases. But you might also have places where you're just counting an array in some somewhat odd way that you don't think you need to use again. And so to do that, you create an anonymous class, pass it right in, and that contains the logic. Now, one of the places where and again, I'm not going to go past today's lesson, but one of the places where it's worth pointing out that this falls down a little bit is that we're still having to, like, there's a lot of, noise here, right? I mean, if you think about it, the logic that I'm passing is right here. That's it. And it would be great if I could just pass something that looked a lot more like that, and we'll see how to do that tomorrow. But for now, it's worth just pointing out that, and these anonymous classes, I mean, it's like I've got this new should count, I've got this whole method declaration, which, by the way, looks identical to the one in the interface. And then I've got a return statement, but really the logic, right, the decision-making logic is all in here. And so is there a way to make this cleaner? There is. Come back tomorrow, we'll talk about it. All right, questions on, I'm going to stop rambling, questions on anonymous classes. Oh, it's just a fun fact about Java, which I've sort of chosen to conveniently ignore. And I actually didn't know this until I started preparing the material for this lesson. And the reason is because it's not very useful, which is why I'm not teaching it. But I just thought it was fun to point out. Check this out. Class, whatever, public, void it. You can create classes inside methods in Java. And I don't know, whatever. So let's give this something to do so that we know it works. And then we'll say whisper, or whatever, sorry. whatever is equal to new whatever, and then we'll call that method whatever.greet. So this is something in Java that's known as a local class. A local class is defined in the body of a method. It's not available outside that method body. I've written a lot of Java code. I have never found the need for something like this, which is why we're not teaching it, but I just thought it was worth pointing out, just for fun, for the people that show up to the walkthrough and anyone who might watch it later, just as a little fun fact. This is not something that, again, I've omitted this because, I don't know, it doesn't seem very useful. But I was sort of surprised that you could actually do this, but there you go. So if at some point you're writing a method and it's like, oh, I need this class just inside this method for some reason, you can do that. So, all right, questions on anonymous classes. I am here for you for another 20, 30 minutes. Fire away. One of the other reasons we're doing anonymous classes, by the way, and not local classes, is tomorrow, right? Where we get to talk about land of expressions, because anonymous classes are the pathway to get to there, and that is actually something really nice, right? It's something that I wanted you to see, and I think is worth seeing, and that you will see in the wild, because it's a pretty cool feature of Java and something that's pretty useful. So, all right, questions, concerns. Oh, that's a great question. I have no idea. I don't know how big that counter gets. Yeah, I mean, you could try it, right? I mean, the anonymous classes all have to be in scope at the same time, which is also kind of strange. So, but yeah, I have no idea. At some point, yeah, maybe that counter breaks, but it's probably like an int, so it would take a while to break. I mean, keep in mind, an int goes up to what in Java, like 2 billion. Every anonymous class takes up some amount of space. And so it's pretty probable that you'd run out of memory before you would hit that limit, but it could be worth a try. Yeah, I don't know. It is, yeah, the anonymous class naming is interesting, right? I had never seen a compiler error message with one in it before, but it is true that they are anonymous. So actually, for fun, let's see what it prints if we say, let's use reflection to get at the name of this guy. I'm just interested to see what this would print. Yeah, okay. Yeah, so it prints that $sign in the name. That's useful to know, actually. One of the things we were trying to figure out for today's homework problem was how to make sure that you guys don't use inner classes. We will talk about inner classes later in the semester. An inner class, since we're just doing like class trivia, an inner class is defined within another class. So here's an example of an inner class. Inner classes can be defined in local classes. They can be defined in top-level classes. They cannot be defined in anonymous classes. they're not very useful in other classes, but they are quite useful in some of these other ones. So actually, we'll use inner classes later in the semester as we move forward and do some more things together. And so we'll get there, but anonymous classes are more immediately useful to us. Yeah, let's see here. In Java, could you take an example counter method and a set flag? That would. Could you take the example and add a set flag argument that would map a pass flag to the logic? So the question is like, could I think this is the question. It's a good question. Help me clarify if I'm wrong about this. So the question would be, could I take my like original count array method that I don't know where it went. Oh, I got rid of it. Let me just go ahead and refresh the page because that'll give me a new copy of that. Yeah. So could I take one of these and add some sort of argument to tell it what kind of count to do? You could, and it would get awful really quickly in terms of just like supporting. Because think about it. I mean, part of the problem is even if you did that, you're never going to be able to support every type of count, right? So for example, one way to do this would be like, oh, if I need to count a range, I'll just create a count array range function and have it, take two arguments, a top and a bottom, and you could do that, right? And pretty soon you would have like a whole family of these functions running around. But at the end of the day, they're all really similar because that counting structure is going to be the same in every single one. And so, and again, this is probably one of these places where you can see a little bit the power of a different model of programming, because what we really did when we rewrote the count function is we applied some techniques from what's called functional programming, right? Instead of having every function need to do all the work, we said, okay, what I really want, like I said, what I really want to do is I want to pass a decision function to this that can do the work for me, right? Because then that decision function could be arbitrarily complicated, right? There are some use cases where you want to count like really strange stuff, right? And so you might have some very, very custom, to be honest, I've used this feature before in Code Ivory, right? Where it's like I have some data and you're trying to basically go through every item in it and produce some sort of count. And sometimes, like imagine this, if this took like an array of objects, right? Those objects might have state, the state might have multiple variables. And so on some level, like trying to support the entire world of potential counting functions just by taking more arguments is a losing battle. You'll just never get there, right? Whereas if I just, and so it's sort of, on some level, it's sort of like punting, right? But it's a very powerful form of punting, right? Where I'm saying, I don't know how to count things. You tell me, right? I mean, that's where the interface comes in. That's our contract, right? Our contract is, I will have a loop here that counts stuff. You will tell me what to include. And that's how things are going to work, right? And again, counting is a particularly simple example, but there's actually lots of cases, particularly when working with. So another example that I didn't do here because it's a little more complex and is a better fit for a data structure that we're gonna get to later, is filtering. So I've got a list of items, and I want to remove all the items except ones that pass some criteria. So that's another case where this is a very, very powerful approach. So I say, look, I've got this code that does the right thing. And that code is not code that you can't write, but it's really tedious to write. You don't want to spend your whole life writing that stuff. It's boring. Someone already did it, right? So you call this filter function. And the filter function says, look, I got the loop sitting right here. It's all ready to go. You just need to tell me what to include. And so you pass, essentially, the decision-making logic to the filter function. And it applies it, and it gives you back a new list only containing the elements that you wanted. So similar things. You really just want to use flags. I mean, you can try, right? I mean, but on some level, I mean, it's like I said, it's a losing battle, right? You'll never you'll never handle every case. And I know that the solution that we get to in this walkthrough may not seem particularly satisfying. And so before you run off and start your flag-based version, just wait till tomorrow. because I think by the end of tomorrow, I'll be able to convince you this is a better way. Because Java's syntax that we're going to look at tomorrow for better supporting this type of thing is really nice. And so, I think you'll be actually pretty surprised at how elegant it is. And it really is, like, you remember we said before, we really just want to pass this, right? All I want to do is I want to call count array, and that's all I want to tell it, right? Because inside this whole bit of blobbity blob, right, that includes an override annotation and a new instantiation of an interface, and an anonymous class, and a body, and a method, and a return type, and all this blah, blah, blah. This is all that matters. If I wrote 5 different filtering functions, I would just change this code. And so tomorrow what we'll see is there is a way that allows us to almost just pass that, right? And then at that point, it's like, hopefully you'll, I'll be able to convince you that the flag approach is not the best, but I'll try at least. Good question. Other questions about anonymous classes. Good questions. Yeah, so and really, like I said here, I think the broader argument I want to try to make today, tomorrow, in the future is for really more of a sometimes referred to as a separation of concerns. So, when we look at these implementations of our counting function, the problem here is that we're mixing two things together. There are really two parts of this. There's the structure for counting that involves creating the counting variable, iterating through the loop, running a test, and then returning the counting variable, incrementing the counting variable if it passes. That's one part. And then there's the logic for determining what gets included. And if I can separate those, then things, so remember, this was one of the things that was so cool about comparable. You've got all this sorting code that will work automatically as soon as you implement comparable. And so in Java actually has a bunch of built-in functions for doing things like counting and filtering and stuff like that. All you have to do is tell it what to count, right? What to include. And it's the same type of thing. So by restructuring this code around the idea of an interface, it allows me to kind of really break it into those two pieces in a really elegant way, right? There's the counting structure, and then there's the decision-making part. And I can actually express them separately, which creates code that is much, much more powerful and easier to maintain, right? I mean, again, let's cut and paste this stuff over and over again. I mean, trust me, like if you go, cutting and pasting is probably more vilified than it should be. There are times when, if you have two pieces of code that are similar, the right thing to do is to actually just write two functions that look similar. The problem is sometimes when people start to see things like this, they get excited and they're like, oh, I can make all my code really general by refactoring these certain ways. And then they start to, and sometimes by the time you're done, it's like, it's not really that much better. So again, over time, I've learned don't, just because you have two functions that look similar doesn't mean that you should try to write one function that rules them all, right? Sometimes two functions that look similar have a small difference. It's actually really, really hard to tease out. Sometimes 3 or 4 or 5 functions that look very similar have small differences that are really, really hard to tease out. Now, again, once you get to like 4 or 5 or 6, sometimes it is time to stop and be like, wait, is there a pattern here? And can I write this function in a more elegant way by kind of figuring out what's different about it and writing a function that allows me to provide the difference, right? That keeps all the comment structure and allows me to pass in the difference. And sometimes there are ways to do that. But it's not something that you want to necessarily rush into. It should happen more naturally than that. There's some people that are like, oh, as soon as you cut and paste code, you've done it's a terrible bad thing, and that's not true. Most like life, most things in computer science and programming that people are dogmatic about, they're wrong. There's just a lot of nuance out there in the world, which is what makes life fun. All right, other questions about this? I know there have to be more questions about anonymous classes. This isn't like the most straightforward material, but it's fun. More questions on recent homework? Anything that's on your mind? I'll stick around for a couple of minutes, hoping that hoping that people chime in. Otherwise, I hope you guys are excited for tomorrow's lesson. It's pretty good stuff. It's sort of, tomorrow's lesson picks up here, builds on it, and brings us to a really nice place in terms of syntax, right? And again, one of the things that I do, one of the reasons why we're doing these things is because when you guys start working on the project, these are some concepts that you're going to need to see. Our approach to the project is different this semester. We're not rushing it out. We're holding it till we think students are ready to see it. And so these are kind of a couple more things that just actually really do come up quite naturally in Android. You see this, right, in code that you will read as part of tutorials, as code that you will need to write, right? You will see the use of anonymous classes and the use of lambda expressions, which we cover tomorrow. So this is part of the real world of Java programming. Yeah, there's a company. I wish I still had the coordinates. I can look it up. There's a company that will print these for you. I wish I still had the design too. They're really nice. Okay, well it's Contrado. Here, let me. I'll get the name of the. This was a neat company actually. I was pretty impressed with their stuff. There we go. Now I'm doing ads as part of the walkthrough. Yeah. So this is where I got them. And I have to say these are really nice. The only thing I don't like about them, and maybe it's just I got the wrong size, is that they pull on my ears a little bit, but that's okay. I think when this pandemic is over, everybody in America is going to have ears that are a little more stuck out than they were when we started. That'll be, you'll be able to identify Americans around the world. It's like, oh yeah, just look at the ears. So yeah, I wish I still had the template for those. I don't think I do. I think it's lost to the sands of time. But yeah, the logo is available. You can send out a link to the logo, and then you just have to get the background color right. That was the only other trick. All right, this seems like a good place to stop for the day. Hope everybody's doing okay. So tomorrow is our last lesson on object-oriented programming before we set sail for the third half of the semester, which will start on Monday. One last topic, I think really nice stuff, right? I mean, Java, from a syntax perspective, is not always an elegant language. The feature that we're going to look at tomorrow is one of the exceptions to that rule. And it also kind of builds on everything that you guys have seen recently, interfaces, anonymous classes, and it's neat. So I will see you tomorrow, and we'll talk about lambda expressions.